Okay. Now the problem here is if you have 100 customers, then you're simulating each driver individually. Okay. And when you have lots of inputs, right now we have 100 inputs. That's the reason why at-risk takes a little bit of time to set up the simulation model and start running. So if the number of customers, usually it'll be in the millions, if not um, it'll be at least in the hundreds of thousands, if not millions. So if you have to simulate each individual driver separately, so you'll have million rows, then it's going to take forever for at-risk to set up. Not to mention that your spreadsheet is going to be so large. So there must be a different way of doing this. And that's this alternative calculation. And there is a little problem with the alternative calculation. We will get to that in just a minute. So here what we're going to do is a large number of insured, the number of successes out of n independent Bernoulli trials is binomial distribution. So we can use binomial distribution. So use binomial distribution to simulate number of claims. That's your frequency. And use number of log normal actually. So this should be log normal distribution to simulate the severity, and then multiply the two, and then you have the cost. But there is a problem, because what you're doing is you're simulating the severity only once. So you're simulating frequency, and then for each and every one of those claimants, there is exactly the same amount of claim, which is not really realistic. But we can take care of that. But first, let's set up the unrealistic one. So here, number of insured, so that's your n. So how many of them will make a claim? So each person making a claim, the probability is this. So we can use binomial. All right. So binomial distribution with okay, so that's your n, and that's our p. Okay, so that's going to give us the number of claims. Okay, and the claim amount is risk log normal with that and that. Okay. So now total claims dollars will be number of claims times the claim amount. Administrative cost is 10%. So total cost is total claims plus administrative cost. And then, so you take that and divide by number insured. So that's your average that you want to recoup. Okay, all of this is dollar. Okay, so that's our model now. Yeah. Okay, so now let's say, how are we going to, okay, we will do the simulation all at one time. So you can use RiskCompund so that this claim amount log normal is repeated the number of times that we're going to make claim. So this RiskCompund allows us to do that. So this is so that's your RiskCompund with the frequency and severity, and simulate severity individually for each claim. So you have 10, comma G10. Okay, so that's going to generate the total claim amount. So it's going to generate both. So it will generate the number of claims and then run this as many times as this is, and then give you the full amount. So then you multiply by that to get your administrative cost, and then you add the two. Well, so here I guess we're going to do the mean as we sum. So you divide by the number insured, so we get the mean claim. Let's call that compound. Okay. And we'll have this as an output and that as an output, and we already have this as an output. Oh no, okay, well, not that one, this one should be an output as well, so we can compare the means. Okay, alright, setting, alright, so now it's simulate. Okay. So now we get about the same. Let's do an overlay. So that's average claim. We'll add an overlay with mean claim. So that is with independent. And then we'll do another overlay for the compound claim. Okay. So you can see how the compound claim is slightly higher, and we can probably zoom into, so let's change the axis option, say to auto, so minus 500, let's make that 0, and maximum say 2000. So then we can look at the different models giving you different answers. So average claim, and that one, so it's more like a binomial, I guess. And then this is your compound. We are still with 100 insured, so we'll look at it, scaling it up in the next video.